Hi, today we are tackling derivative fluency. We are going to solve common textbook exercises using the power, product, and quotient rules. Think of these as your basic building blocks for understanding how functions change. We focus on three primary rules: the power rule for simple terms, the product rule for multiplying functions, and the quotient rule for division. These are the foundations of all derivative math. Calculus is ultimately about understanding how things change. Mastering these rules helps us calculate that change with perfect precision. Let's get started. The power rule is our most useful tool for polynomials. To find the derivative, bring the exponent down to the front and then subtract 1 from that exponent. For x to the power of 7, we move the 7 in front. And for constants like 10, their rate of change is 0, so they vanish. Simplifying this gives us 7x to the power of 6. That is our final derivative. Look at this function. F of x equals x squared times the sum of 2 over x squared and 5 over x cubed. You could use the product rule, but that gets messy quickly. Instead, distribute the x squared first. That simplifies the function to 2 plus 5x to the power of negative 1. Now, differentiating is easy. The derivative is just negative 5x to the power of negative 2. Always simplify before you start differentiating. When you see a function divided by another, use the quotient rule. Think of the mnemonic: low d high minus high d low over low squared. Let's apply this to the function x squared plus 4 divided by x squared minus 4. Identify the high and low parts and their derivatives. Now plug these into our formula. The derivative becomes the product of the bottom and the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Finally, simplify the numerator. The 2x cubed terms cancel out, leaving us with negative 16x over the denominator squared. Remember, sometimes it is easier to simplify the expression before differentiating to avoid the quotient rule altogether. Why do we learn these complex derivatives? In 2026, these aren't just textbook exercises. They are the foundation of machine learning. Complex structures like this quotient, found in exercise 117, represent the layers in neural networks. We calculate derivatives to find the gradient. The gradient tells an algorithm which way to adjust its parameters to reduce errors. If you can derive these complex functions, you have the math to calculate the slope of almost anything. You have done great work mastering these rules. To wrap up, here are 3 essential tips to ensure you excel in your calculus journey. First, always rewrite your fractions as negative exponents. This transforms a tricky quotient rule problem into a simple power rule problem. Second, look for opportunities to simplify your expression before you start differentiating. A few seconds of algebra can save you a lot of work later. Finally, practice your algebra regularly. Calculus is mostly just applying these rules to algebraic expressions. so fluency is your best friend. Keep practicing these foundations. Remember, the complex stuff will become second nature as you go. You've got this.